Today in class we focused on markups, markdowns, and discounts. And we learned one way of doing the problem, but I'm also going to show you a secondary way of doing the same type of problem that might align a little bit more closely with how we did the taxes, tips, and commissions. However, just like taxes, tips, and commissions, it was a two-step process rather than a one-step process. The big idea behind the markups and markdowns is it is a one-step process that will essentially mirror some more of a formula-based process for solving the same type problems as you get into older subject areas. So looking at problem 1, what is the selling price of a $600 computer with a 80% markup? Now, you're probably not going to see 80% markup, but who knows? By the time you some of these products really roll off of the sales for and the actual cost that it is involved in making some of these simpler products, they actually do have quite a bit of markup once you track down all the hands and shipping and labor and legal fees and everything else that goes into the development of the product. So 80% might actually be somewhat realistic. Regardless, when we look at selling price and the 80% markup, we discussed in class that 80% markup was on top of the 100% of the actual item. And so this was the one-step process. If 100% of 600 would be 600, I would need to take my 80% and add that to 100% and set up a proportion like the following. 180% of 100 is equivalent to something over 600. And basically what this equation is, this proportional setup is telling us is that if I pay for 100% of this item, that would be $600. If I pay anything beyond 100%, now my price exceeds just the $600 selling price. And so now I can cross multiply 180 times 600 is going to equal 108,000. Multiply the other two, 100 times x equals 100x. And now we divide by 100 on both sides. And my value of x equals $1,080. Now my value of x already reflects the total price of my computer's selling price plus the 80% markup. So I don't need to do anything else with my solution other than what's already there. A secondary option for solving the same type of problem, x over 600 is equal to 80 over 100. And so when I multiply 80 times 600, I get 4,800 equals 100x. Not 4,800, 48,000. Helps if I write my numbers down correctly. 48,000 divided equals 100x. So when I divide both sides by 100, then I get x equals 480. Now again, we're talking about an 80% markup. So if I'm going to have an 80% markup, then my value that I determine cannot be less than my original selling price because that would be a reduction in price. Rather, this markup, $480, is how much is getting added to the original cost of my computer. So now I would need to add in to that value the original cost of the computer. And again, I have 1,080 as being my total. So there's two ways to think of it. I prefer to go ahead and use the original one-step way, but if that still presents a problem and is confusing to you, either way will get you the same answer. Now I want to do one more problem, number 5, just to show you a little bit of the thought process behind some of the multi-step problems that are in this worksheet for you tonight. A company receives 500 shirts and will be billed $20 per shirt. The company is going to mark up the shirt price by 40%. What is the profit that will be made on the sale of a single shirt? Well, the cost of a single shirt is $20. The markup price is 40%. I'm going to go ahead and use the one-step process. So 140% of $20 will tell me the cost of a single shirt. So 140 times 20, 2,800 equals 100x. Divide both sides by 100 so that I get x by itself, and I find out that x equals 28. Now 28 is the cost of my shirt after the markup has been applied. So how much profit is there between a shirt? Well, if the company was billed $20 per shirt and they're going to sell it for $28 per shirt, they are going to gain $8 per shirt. Now question B asks, what's the single selling price for a single shirt? Well, we just found that out with our X value. $28 for each shirt is how much they're going to sell it for. That will give them an $8 profit on each shirt. Question C then asks, if the company sold every shirt, what is the amount of money it would receive prior to paying the bill for the cost of the shirt? So in other words, at their price for selling the shirt, how much money will they bring into their register? So $28 times the 500 shirts that I'm going to be able to sell tells me that they will bring in $14,000. Now remember, not all of that is profit, because they still have to pay for all of these shirts that they bought, which is where question D then comes in. What would be the total profit the company would make from selling every shirt? Well, I really have two ways that I can do this. I can look at the profit from one shirt and multiply that by 500. So $8 per shirt times 500 shirts equals $4,000. An alternative way of finding the same solution would be to take the 500 shirts, multiply it by the $20 per shirt, and subtract that value from how much money I made selling the shirts. And again, I would come to the same conclusion of $4,000. So yes, there will be some multiple processes that can take place for solving the same problems, but I should see some work that demonstrates that you at least use a logical process for getting a solution to the problem. Punching numbers in a calculator is not a logical process. Yes, you may get the correct answer, but I need to see something on your paper that demonstrates knowledge.